So, when you are solving a quadratic, do you remember what you're even finding? What does it really mean when you solve a quadratic and you get an answer? What is that answer? Yes. Can you be? Yes. It's not just any random point, though. Does that remember? When you solve a quadratic, yes, it's where the graph crosses the x-axis. So how many answers can you get? One. You could get one if the vertex is on the x-axis. Two, or none. Right. Right? Because if you think about a parabola, it's either going to cross twice, like most of them, well, I shouldn't say most, but lots of them do. It could cross just one time if it has its vertex right on it, or it's going to not cross at all. Okay? So, most of the time, well, I take that back. Every time you solve a quadratic, you're going to get two answers. It's just a matter of, here you would get two rational answers. Here you would get the same answer twice. And then here, at this level, you get two imaginary solutions. So I don't get any real solutions. So I'd have 0 real solutions, 2 imaginary ones. And you'll be able to find those imaginary roots in Algebra 2. But any Hoosers, do you remember, if I don't have a graph, how I can figure out how many solutions I have before I go all the way through and solve it, Alexandra? Yes, the discriminant. So that was the inside portion of the quadratic formula, b squared minus 4ac. That answer will tell you which of these 3 options you have. If it comes out to be positive, how many solutions will you have? 2 real solutions. You got it. If it comes out to be 0, you will have 1 real solution. That's this scenario right here where it just hits the x-axis. And then if it's negative, it's no real solutions, but there will be 2 imaginary. Okay? So that's the whole thing. When you are solving a quadratic, you are finding those x values if they exist. All right? That's the whole point. And we have, gosh, how many ways do we have to do it? 1, 2, we have 4 ways. So we're going to breeze through each of the 4. Ready? Okay. So let's start off with the simplest type. You might have something like, I don't know, how about 3x squared equals 75. There's a quadratic, I want to solve it. What would you do? So you could. If I was going to factor, I'd want to do that. So there's a hint. I'm not going to factor this one. Yeah, I can divide both sides by 3. And I get x squared equals 25. And then what can I do? Square root both sides. What is the square root of 25? Yes, positive and negative 5. Remember, when you take a square root, you have to remember both roots, positive and negative 5. So that means if you were to graph this quadratic, it would cross the x-axis at positive 5 and at negative 5. Okay? So this is called solving by square rooting. So let's make a list. How to solve quadratics. 1, the easiest, or let's say option A, I should, because it's not in. Option A, solve by square rooting. Well, that's super easy. Why don't we do that all the time? Because you can't always. You can only solve by square rooting when b is 0. So you can't have a linear term. In other words, I can't have a term that has just an x on it. X squared is fine and a constant's fine, but if I had like plus 4x, I couldn't solve by square rooting. Can't have a linear term. B must be 0. Okay, and there's an example of that. If you can't do that, that's your easiest option, but I can't always do it. If I give you something like this, you can't solve this by square rooting because b is not 0. I have a linear term. So, what's the next best thing? Factor it. If a is 1, you're almost done. Find factors of c that add up to b. So, factors of 9 that add to be 10 are just positive 9 and a positive 1. And then once you get it factored, you just set each factor equal to 0. So I literally have x plus 9 equals 0 and x plus 1 equals 0. And then you just solve each one. So minus one of my answers, is negative 9. The other is negative 1. So there are my two answers. This thing is crossing the x-axis at negative 1 and at negative 9. Does that make sense? So your second option is to solve by factoring. Of course, they're not always that easy. Let's just throw one more in there. Say I ask you to solve, I'll stick it right here. 2x squared minus 5x minus 3. You still always see, can I factor something out of the whole thing? No, I can't this time. So what are you going to do now? What? T's, yes. Trying to get to a negative 5, so it looks like I'll do a negative 6 and a positive 1. So negative 6 means a minus 3 there and a plus 1 there. So there's my two factors, which means I'm ready to set them both equal to 0. So I have x minus 3 equals 0 and 2x plus 1 equals 0. And then I just solve each. One of my answers is 3. The other is a negative 1/2. Oops, sorry. So that is where this one is crossing the x-axis, at those two spots. Okay, so that's solving by factoring. Then you might have a problem like this one. So now I'm here. I can't solve this by square rooting because I have b's not 0. All right. I can try and factor. A is 1, so I just need factors of negative 1 that have to be 10. Well, that doesn't exist. So what do you do now? If I can't solve by square rooting or by factoring, give me another option. So you can do, you're right, if I did the discriminant, it would tell me how many solutions I had, and if it was none, I would get to walk away. I have two choices left. That's part of the quadratic formula. So you could do quadratic formula, or you can complete the square. Now, listen, on your final exam, it'll probably say, solve this problem by completing the square. If you don't know completing the square, I don't think you're magically going to learn it overnight, right? If you haven't learned it after weeks of practicing with it, it's probably not going to come. But if you are decent at quadratic formula, I'm never going to know whether you solved it with the quadratic formula or completing the square. I would have no idea because it's multiple choice. So even if it says solve it one way, if you can't and you know another way, go for it. But here's how you complete the square for those that just need a quick refresher. Does anybody remember? How do you even start? I gotta move C to the other side. A has to be 1. That's the other thing with completing the square. A has to be 1. If it's not, you'd have to divide everybody by whatever A is. So that it can get real messy real quick. But in this case, it's fine, right? I just move C to the other side. Then what do? And then square it. So I want half of B and I want to square it. So in this case, half of 10 is 5, and 5 squared is 25. So that's my magic number that I add to both sides. Oh. Yeah, because I added the 1 in my head. Silly goose. What am I thinking? Good catch. That's better. Okay, so a very common mistake is right here. A lot of times kids forget. They'll either take half or they'll square it. They won't do both. You have to take half of B and then square that number. The other common mistake is to not add it to both sides. You have to add it to both sides. All right, now on the right hand side I get 26. On the left, do you remember what you're supposed to do with that? This left-hand side.
Don't you do x plus 5?
Yes, you're really factoring this left-hand side. So factors of 25 that have to be 10. Aren't they 5 and 5?
Sorry.
It's okay. So just write it as x plus 5 squared instead of writing x plus 5 times x plus 5. But now once you're here, you can square root both sides. So I get x plus 5 equals, now the square root of 26 doesn't simplify, so I'm just going to leave it as positive negative square root of 26. And then I'm almost there. All I have to do now is minus that 5. And remember what we do, we're going to stick it. You stick it right up in front. So negative 5 plus minus square root of 26. And you're done. So this thing does cross the x-axis twice. It's just not at nice numbers. They're really kind of funky numbers, but there they are. Okay, so that's option C in our list, completing the square. I really kind of messed these notes up. Complete the square. And then your very last option is the quadratic formula. Please go ahead and write me the quadratic formula right on your paper from memory. If you know it right now, you're probably going to know it on Friday. But it's probably a good idea to refresh it at least once a day from now until then. And you got to make sure that you have it perfectly, because if anything is wrong on it, you're probably going to get all the questions pertaining to the quadratic formula wrong. All right, so I hope you wrote this. X equals negative b plus minus a big old square root, b squared minus 4ac, the discriminant, right, goes underneath, and the whole thing is over 2a. So you should have it written just like that. Do whatever you gotta, this is one you just gotta know it. So if you have to write it 10 times a day from now until Friday, write it 10 times a day. If you need to memorize the song, go on YouTube. There's songs. Didn't we do the one with the boy and he missed out on 4 awesome chicks? Remember that? Did I play that for you? It's lame, but whatever works. You have to know it, okay? Writing it on your desk, not an acceptable solution. Writing it on that little slip of paper in your calculator, not an acceptable solution. I know all your tricks. Writing it on your water bottle, not an acceptable solution.
You're just giving everyone ideas.
If you haven't thought of these,
I actually had the calculator one. I never thought.
oh yeah, that's a common one. This paper right here. Kids write on all the time. Think they're so slick. You're only fooling yourselves, kids. All right, so when do you use the quadratic formula? When you're trying to solve a quadratic that's awful. I can't factor it, and it's not, oh yeah, remember when is, completing the square is nice when a is 1 and b is even, right? Because I have to take half of that number. So if that's an odd number and I'm trying to take half of it, it gets messy. You can do it, but it's a nightmare, okay? So completing the square is nice if a is 1, b is even. Otherwise, quadratic formula will handle anything. You just have to make sure that you're using it properly. So why don't I give you one? How about negative 4x squared minus 3x plus 2 equals 0. Go ahead and solve this one using the quadratic formula. Remember that before you start solving using the quadratic formula, the whole thing has to equal 0 first. In this case, it does. But if you had, like, I don't know, a plus 7 over here or something, you'd have to make it equal to 0 before you know who A, B, and C are. You don't know A, B, and C until the whole thing is equal to 0. Please don't fall into that trap, because I very easily could have just moved the 2 over, and then you would think that C is negative 2, and you'd be wrong. So, has to equal 0, and there's A, B, and C. If you're doing quadratic formula anyway, you should totally start by finding the discriminant. Because if it's negative, you don't have to do any more math, because there's not going to be a solution. So, and you have to do b squared minus 4ac anyway. So let's go ahead and see what we get out for that. So b squared, negative 3 squared minus 4 times negative 4 times 2. It is so common to mess up the signs. Please watch. If I want to take the number -3 and square it, that comes out to be a +9. Now, look, you have -4 times -4 times 2. -4 times -4 is +16, times 2 is now +32. So I hope you have a plus right there. If you have a minus, you're messing up with your signs. Just call this a -4, and you're just doing multiplication. -4 times -4, +16 times 2. There we go. So I get a 41 there. So I am going to have two solutions. I just now need to find them, okay? So if I pop this back up all into the quadratic formula, x equals -b is now a +3, plus or minus the square root of, I already did that, it's 41, all over 2 times a would be a -8. Is that a final answer? Yes. I can't simplify the square root of 41. There's no perfect squares that go into it. So yes, they will, you'll see your answer probably just like this. Maybe they might divide the -1 up. Tell me if this is a final answer or not. If you had gotten x equals 2 plus or minus 4 root 3 over 8. Is that a correct final answer? What can you do to this? What? Yes, if all, it has to be all three of the numbers. It can't just be, you can't just reduce the 2 and the 8. Because you are dividing not just 2 by 8, but the 4 by 8 also. So it has to be all three of these numbers. If they have a common factor, you can reduce everybody by that common factor. So since they do, I'd get 1 plus minus 2 root 3 all over 4. So that's allowed. And that's important because you're not going to see this as an answer. Right? You're going to see this. So if you don't know how they're getting from this to this, there's no guarantee that even though you did all the right math that you're going to pick the right selection. Okay, so be careful with that. So that's quadratic formula. So that's the gist on how to solve quadratics. The only other thing that was in this unit was stuff like, hey, simplify the square root of 75. 75 is not a perfect square, but what is? It's 25. So you split that up into the 25 and 3, so you got 5 root 3. Remember that? And then you would also, but I think we've done it more recently with our radicals. You might also be asked, okay, well, if I had 6 root 2 plus root 3 minus root 2, could you simplify that? Sorry, I'm trying to conserve space here. What would that become, if anything? Six root 2 plus root 3 minus root 2. Yes, like radicals, remember? Just like variables. So like 6x plus 2x is 8x. But 6x plus 2y, there's nothing you can do with them. So if I don't have like radicals, I can't combine them. I have like radicals right here, 6 root 2 and a negative root 2. So that's 6 of these minus 1 of these. That's how I get 5 of these. And then I just have that plus root 3 that just stays on the end. Okay, so shall we practice this? All right.